Okay, so let's start talking about test 4 stuff. Remember, everything on test 4 is means. No proportions at all, no P's, no Q's, no success, no failure. Everything is means. Everything is T statistics. We won't have any Z scores. Anytime somebody asks you for the test statistic, that will be your T score, not Z score. So the buttons we'll be using on the calculator, 2, 4, 8, and 0. So we'll go in here into stat, over into tests. Everything better say T on it. Again, no props. If you're using one of these buttons, like let's say prop, you done goofed. 2 and 4 are our hypothesis tests. 8 and 0 are our intervals. Okay, so remember the whole key here is we're trying to take a sample, find our sample mean or sample standard deviation, and then use that to make predictions about our entire population. So everything is about means here. So let's look at this question. By the way, most of the questions in the homework from these two chapters, 22 and 23, almost every question has a video. And honestly, those are probably more professionally made than the videos I make. Like, you might be better off just ignore me and watch this guy's videos. I got most of them from this guy here, and they're very well made. So I'm not going to spend a lot of time today going through problems because honestly, this guy's videos are probably better than mine anyways. But I'll go through a couple, like here. We're working backwards. Somebody's already done the confidence interval, and we want to go backwards and figure out what our sample mean and margin of error must have been. So remember, the whole idea is you find a sample mean that's right in the middle of your interval, and then you go up and down by your margin of error. So right in the middle of this interval must have been the sample mean, and I went up and down by the margin of error. So how would you find the number right in the middle of two numbers? You just average them together. That's one way we could do this. So to find that guy, we're looking for the number right in the middle of these two. We could add those two numbers together and divide by 2. That's how you find the midpoint. So is that 362.4? Oops. Add them together, then divide by 2. So 304.6 is our sample mean. Okay, how do we find the margin of error? The same way we've always found margin of error. High minus low divided by 2. Same way we're doing it back on test 3. To find the margin of error, high minus low divided by 2. Write that down. And then divide that by 2. 57.8 looks like I wrote there. Okay, now another way we could have done this, the same problem, is figuring out, this is the number in the middle. How much higher and lower did I go above it? So once I had this, I could have done top minus middle to get 57.8. Or I could have done middle minus bottom. Or I could have found the margin of error first, high minus low over 2, and then just did high minus the margin of error to get the guy in the middle. Like, I had a bunch of different ways I could have done this. It's understanding what the interval means, understanding what all these symbols mean, and that's just basic arithmetic here. This is literally the same kind of question, only now we're going the other way. Now they've given us the sample mean And the margin of error, we want to write it back in a form like this. So just middle plus the margin of error will be the high, middle minus will be the low. Okay, let's actually do one here. Let's find a margin of error. Okay, so and the easy way to do this is just build the confidence interval and then do high minus low over 2. There are more complicated ways. We could go find our t-score. We'd have to find our degrees of freedom. We'd have to go through a whole lot of work, go find a z-table or a t-table in the back of your book. We could do this by hand, but it would take 15 minutes to do a very simple problem. We've got this fancy calculator. Let's just use it. So let's actually calculate this confidence interval. Okay, I only have one sample here. The way I know that, I only have one sample size. I only have one sample mean. I only have one standard deviation. This is a one sample interval. That'll be button 8. Look at button 0, that says 2 sample t interval. First off, we know we're doing an interval because it says confidence right there. We know we're doing an interval. We don't want it to say test. Secondly, we know we only have one sample because they literally only give me one sample. If I go into button 0, look at all the stuff they ask for. I don't have all that. The only thing that makes sense, literally the only button that makes any sense, is button 8. Okay, now they give me the statistics. I don't have a list of data. We'll do one like that where we have all the data, but they give me the statistics. And just like with test 3, if you don't know what the symbols mean, you're out of luck. You're going to do terrible on this test. You have to know what all the letters mean. That is the sample mean, X bar. That's 22 right there. The sample standard deviation, SX, 19.1. N is the sample size, has been. Oh, I lied to you. I lied to you. That was sample size there. There's sample mean, 66.9. Sample size was 22. My confidence level is 90%. That will be 0.90. Hit calculate. We're done. There's our confidence interval right there. What the question asks for, though, not the entire interval, it only wants the margin of error. So now I'm just going to work from here to get the margin of error, and that's always high. I wish they hadn't disappeared off my screen. I guess I would have to write those down. High minus low divided by 2. I have to remember them. What was that, button 8? Okay, so 73.9 minus 58.9. I'm rounding a lot here because I don't feel like writing all this down. Do the subtraction, then divide by 2. So it's 73 and 59. Hit enter, then divide by 2. Okay, so I rounded a little bit. It's not going to be exactly 10. Wait, did I type something wrong? How are they getting 7? I got to check my math now. Because I didn't round that much. T interval, 66.9, 19.1, 22. Yeah, that all looks right. The mean, the standard deviation. Oh, it was 59.9. Sorry. I should have written all this down. 73.9 minus 59.9, then divided by 2, 7. Okay. Everybody that's watching the video probably realized what I did. Okay, here's a complete problem. That one's got a written example that I wrote up and a video by that other guy. Exact same kind of problem. Here, though, we're looking for the entire interval. So, like, literally, it's just picking out the numbers that you need. Like, I don't even have to, honestly, I really don't even have to read the whole question. I should, but really, it is just a matter of, okay, there's my sample mean, 5.7. There's my standard deviation, 2.3. Sample size, I got to be careful. Sometimes they'll give you the population size and the sample size just so you can check the conditions and make sure your sample is large enough. You got to be careful with that. But here they don't do that. They only give me the sample size 70, and then my confidence level 0.99. Hit calculate and we're done. That's the entire problem. So 5 to 6.4. Okay, what if they give us the data instead? Okay, so there are a couple of different ways we could do this. We could, because they've given me the sample data, I could go back and think like we did on test 1 and find the sample statistics. So I could come here into stat, over to calculate, one variable stats. Remember when we had to do this and we type all our numbers into the list and so forth. So let's type our numbers in. I'm going to go into edit. I'm going to clear L1. The easiest way to clear that is highlight L1, hit clear, and hit enter. And now I'm just going to type in all my numbers. This shouldn't take too long. If we have repeats, we've got to make sure we type them all. .6 and 3. Order doesn't matter here. If you accidentally mess up and you forget one, you can put it at the end. I like to count. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I typed in 10 numbers. So hopefully I typed them all right. Now I could, if I wanted to, come here to stat, over to calculate and do one variable statistics. And there's my sample mean right there. Here's my sample standard deviation. I could write those numbers down and do this problem exactly like I did the last one. In fact, that's the first thing they asked for there, the sample mean. See right there. That's my point estimate. That will be in the middle of my interval. Or I could skip that step and just do everything at once by coming to stat, over to tests, down to number 8 again, T interval, and tell the calculator, look, I think it already put my stuff in for me, but just tell the calculator, I have the data and it's all in L1. That's where the data lives. Leave that frequency alone at 1. And let's see, 98%. Hit calculate. And look, it does it all for me. Like it spits out not only the interval, but my point estimate, the sample mean, and my standard deviation, and my sample size, all the stuff I could want. Right, there's checking the conditions. Here's the interval. Notice how they want us to type the interval. Remember what a confidence level means. It means 98% of all the intervals of that size would include the true population mean. Okay, so now you've got this interval. You're 98% sure that the real answer is someplace in here. Then this question says, well, is it possible that the real population average is 2? That's not inside my interval. It's possible, but we're 98% sure it's not. Like, we're more than 98% sure that the answer is not 2, because we're 98% sure the answer is between these two numbers. Okay, these are similar questions. More confidence intervals. And then we get to hypothesis tests. So again, the calculator will do it all for us. For a hypothesis test, we're going to use buttons 2 and 4. On this homework, it's all button 2, because all, like, literally this entire chapter is one sample statistics. We only have one sample. Okay, that one has a written example, so I don't want to go through the whole thing. Video, and so forth. Again, with this one, we could type all the data into L1 and let the calculator do all the work for us. And see, again, a lot of these have written examples. Okay, let me move on to chapter 23. Now here, we're comparing two groups. Still all T's, still means, no proportions, no success, no failure, but we're comparing how much higher group 1's average is than group 2. So if we wanted to do a confidence interval here, we're estimating the difference between these groups, how much higher group 1 is than group 2 on average. So this would be a 2 sample interval. Button 4, no, that says 2 sample test. Button 8, look at all the numbers I have there. I've got X1s and N1s and so forth. That ain't gonna work. If I go in there, no, that won't work. Button 0, 2 sample interval. See, look, literally all the stuff right there is what the calculator is asking me for. And like, we literally just type it all in. 3, 66, 36, 62, and 5. And what was my confidence level? Oh, right there, 96. That's the one people forget to change. They'll type all that in and then forget to change this one. For pooled, always say no on pooled. And there's our interval. Well, evidently I just keep typing stuff wrong today. 36, what did I type wrong? 3. Oh, I got these two backwards. You guys don't need to go and watch me retype that. Obviously, you probably watched me type it wrong as I was typing it. So I got S2 and N2 backwards. Same exact problem. Here, Now, they don't even ask me to do it. They're just asking what you would do, what button you would use, basically. But if I wanted to do this interval, I could type A into L1, B into L2, and then tell the calculator to use those lists. Okay, so here, they tell me who to use for L1. They say, or for group 1, female, excuse me, will be group 1, male will be group 2. So here, let's actually do this one. So if I were doing this problem completely, first thing I would do is start writing stuff down. Let's actually write one out. We're not going to have a meeting on Thursday. I have to go into campus. So I'm going to go a little longer, I think, today. And then we won't have a meeting on Thursday. Let's actually write this one out. It's not letting me type. Okay, so let's take a look at this problem. First thing we want to do is define our variable. What is it we're trying to calculate? What average are we trying to estimate the difference of? So we're talking about number of hours people work, the average number of hours. So let's say that. Let mu represent the average number of hours. This is not writing. I'm getting a new laptop on Thursday. So I've been cleaning up this one, getting it ready to import all my documents over to the new ones. I've been cleaning up a bunch of old files, getting rid of stuff. And I think I messed up something here with my notability. Like it's not writing. Pause again. Okay, so let's try this again. Get this full screen. First thing we want to do is define our variable. Let mu be the mean number of hours worked. Remember, we don't want to mention the groups there. We're talking in general. Our population is what servers at this bar. Well, this bar has a lot of servers, don't they? I don't know how realistic this question is. They got just in this sample, we've got a sample of 120 servers. And remember, our sample shouldn't be more than 10% of our population size. So this bar would need to have at least 1,200 servers. Obviously not a realistic problem. But we don't mention those groups when we're defining our variable. We're trying to define mu here to be the mean of all the servers. Okay, then we have our groups. We're going to have group 1 and group 2. Typically, I recommend the group with the higher sample average, let them be group 1. That makes writing this interval a lot easier because you're less likely to get negatives. But they've told me which one to do. I don't have a choice. They want mu1 to be female, mu2 to be male. So these will be the female servers and the male. Each group is going to have their own sample mean, standard deviation, and sample size. Okay, so what do we have? Both sample sizes are 60, 27 and 5 hours, 5 hours. And these were both 60. And then for the male workers, 25 and 2. Okay, that's our setup. Now the calculator does all the work for us. Remember, on written assignments, I want you to write all this out. So we're going to go down to button 0. This is a 2 sample interval. We have the statistics. I like to write things in this order too. Since this is the order calculators ask for it in, I like to, that's how I got that last one messed up, because I'm just used to typing things in this order. X bar, S, then N. And then over here, 25, 2, and 60. Don't remember what confidence level they want. 80. What a weird question. 86%. Okay. We always say no on pooled. We hit calculate. There's our answer. 0.96. I'm going to go to 2 places here. We'll look in a minute and see what the question, how they want it rounded, but 0.96 to 3.04. Okay. Now, what does that mean? What did we just figure out? None of these are percentages. The only percentage anywhere on this problem is the confidence level. None of these other numbers are percents. Don't put a percent. Don't move any decimal points. These are number of hours. That's 3 hours. That's an hour. You know, 0.96, and we round, that's an hour. That doesn't mean anybody worked for 3 hours. This is how much more group 1 is on average than group 2. So it's, we are 86% confident that this mu for group 1, the mean number of hours, the females work, is between, don't forget the word between, this and that, more than, so 0.96 and 3.04 hours, not percent, not dollars, hours more than the mean for men. Okay, there's the entire problem. And then the question is, based on that, who do we think won? Like, who wins this game? If both numbers are positive, group 1 is the winner, so to speak. If both numbers are negative, group 2 was the winner. If you get a negative and a positive, there's no winner. So here, we're pretty sure the female servers are working more hours. How many more hours? We think it's between 1 and 3, but we're only 86% confident of that. And that one has a written example. Let's do a hypothesis test. Okay, so we want to, here, we'll do number 10 here. Test this claim that the GPA of night students is bigger than GPA of day students. So we've got 2 groups. So the first thing we're going to do is define our variable. So let mu be the mean GPA. Are they going to let me? Yeah, they're going to let me choose who I want to be group one. They use symbols instead of 1 and 2. I'm going to write this out using 1s and 2s, and then we'll translate it back to what we have here. So I'm going to call group one the one that has the higher mean, sample mean. So we get those down here. The night students have a sample mean of 233. They're higher on average in the sample than the day students. So this is night and day. So we'll have an X bar 1, an S1, and an N1. Remember, on any written assignments you got to turn in, this is all required, writing all this out. So I wanted to do a couple of these by hand. All right, what numbers do we have here? We'll get to writing the hypotheses in a minute. 20 night, 20 day, both of the ends are 20. I think this was 233 and 231. Yep. And then my standard deviations, 0.05 and 0.07. Okay, then our hypotheses, my null hypothesis, if I chose correctly, if I got to pick my groups and I picked group one to have the higher sample mean, then every single time your null hypothesis is mu1 minus mu2 is positive, or sorry, nope, not yet, equals 0, or equivalently, mu1 equals mu2. And then your alternative is mu1 minus mu2 is positive. Or again, alternatively, this means the same thing. Mu1 is greater than mu2. If you get to choose, and it's a one-sided test, these are going to be your hypotheses every time. You can write them like this or like that. Doesn't matter. Okay, now instead of 1s and 2s, they use nights and days. We don't want any P's, no P's anywhere. That's for proportions. That one's out. We want night bigger than day. Now, notice how they're using, instead of equal to like I did, they use less than or equal to. That's an alternative way to do hypothesis testing. You'll notice in every example I do, I always, here in the null hypothesis, always have an equal there. Another way to do it, the way I learned when I took this class, well, if that one's greater, this one will be less. Whatever this one is, that one will be the opposite. But that just confuses the hell out of students. So I don't teach it that way. I teach it that we always put an equal here. Whoever wrote this question teaches that, well, if you put a greater there, we're going to put a less than here. So you figure this one out first, and that tells you what to put here. And that's what this question's asking us to do. This is the correct answer. Because we got the greater than, night is greater than day in our alternative hypothesis. This is, we got a greater than, that makes it right-tailed. And now the calculator is going to do all the work to get all these. So we're going to go stat, over to tests. This is a hypothesis test. So our button better say test. We have two groups and we have to say T. It's always going to say T. So the only button that works is 4. We know all these sample statistics. So we just type them in, 2.33, 0.05, and 20, 2.31, 0.07, and 20. And then the alternative we wrote was greater than. When the question asks for the sample, the test statistic, that's the t-score. That's that right there. This is the number we really care about, the p-value. That's a capital P. I know that doesn't look like a capital P there, but that's a capital P. That's our p-value. That's the probability of getting a sample that looks like this if the null hypothesis is true. And it was like 15%. It was gigantic. Yeah, 0.15. Remember, small p-values are strong evidence against the null. This is a gigantic p-value. I don't even know what the alpha level is, but that's bigger than the alpha. Did they give? I don't even think they gave us an alpha. I think they meant to right there. It says at the significance level, and then they forgot to type a number. The significance level, if they don't give me one, I'm going to use 5%, but it doesn't matter. The only P or alpha levels we really ever use are 1%, 5%, and 10%. That p-value is bigger than all of them. It's gigantic. So our p-value, if we use, say, 5% for alpha, the p-value is bigger than alpha. Bigger than alpha, we fail to reject the null. We don't draw any conclusions, and we say we do not have strong evidence. That this line, mu1 is bigger than mu2. Well, what did mu1 stand for? Oh, it's a good thing I wrote this down. The mean GPA of group 1. We do not have strong evidence that the mean GPA of night students is greater than, and so forth. Or I could say is more than the mean GPA of day students. Okay. All of this, everything you see me writing, would be required on any kind of written assignment, and then answer any follow-up questions. So here we failed to reject the null. There's our p-value. Okay, on say this one, I would not calculate the sample statistics myself. I would type all these in L1 and all these in L2. And then when we go to do the 2 sample test, oh yeah, we're doing a test here. I could go here to data and say, I have the data. And I would tell it my list there. L1 is the first one, obviously. Okay, with all the other videos and written, I think that should be enough. If you have any questions, feel free to reach out. We'll do more examples next week, and then we will review for test 4. And then after that, all we got left is the final. We'll review for the final.